Project Fakel became one of the most unusual and radical engineering operations of the 20th century, carried out under the strictest secrecy in the Soviet Union. The story began with a technological disaster at a major gas field, where during drilling, a well with abnormally high reservoir pressure was breached. Within seconds, a massive gas blowout occurred, followed by a powerful explosion. The drilling rig was destroyed, and a gigantic column of fire burst from deep underground. The flame rose hundreds of meters into the sky, forming a continuous inferno visible from dozens of kilometers away. Temperatures at the epicenter were so extreme that metal structures melted and the surrounding sand fused into a glass-like crust. Approaching the source of the fire was nearly impossible. Machinery failed, and protective equipment could not withstand the thermal load.
The blaze burned for weeks, then months, releasing colossal volumes of gas and combustion products into the atmosphere every single day. Economic losses mounted rapidly, along with severe environmental damage. Engineers and firefighting brigades attempted every conventional method available at the time. They tried burying the well with sand and clay, flooding it with high-pressure water, and sealing it with reinforced concrete structures. Directed conventional explosions were even used in attempts to collapse the well walls. But the gas pressure repeatedly blasted through every barrier, reigniting the flames again and again. It became clear that standard technologies were powerless. During closed government meetings, a proposal emerged that seemed both brilliant and terrifying: to use a peaceful underground nuclear explosion.
At that time, the country was already researching so-called nuclear explosions for the national economy, exploring their use for creating underground storage caverns, canals, and stimulating resource extraction. Now atomic energy was being considered as a tool to extinguish a catastrophic fire. The concept was precise. Engineers would drill a diagonal relief shaft aimed toward the damaged wellbore, reaching a calculated depth as close as possible to the gas escape channel. A compact nuclear device would then be placed into this borehole. Its yield would be carefully calculated so that the detonation would not rupture the surface, but instead compress and shift underground rock layers. The explosion would collapse the gas pathway, hermetically sealing it. Preparation for the operation took months. The disaster zone was declared a restricted area, access tightly controlled, and all work conducted under military and nuclear industry supervision.
Drilling the angled shaft became an engineering challenge of its own, requiring extreme precision, as even minor deviation could nullify the blast's sealing effect. Once the borehole reached the target depth, the device was lowered several kilometers underground, connected to detonation systems, and the shaft was sealed. Before the explosion, all personnel were evacuated to a safe distance, heavy equipment withdrawn, and monitoring stations prepared to record seismic and radiation data. The detonation marked the climax of the operation. On command, a powerful subterranean shock occurred. The ground above the well briefly lifted into a dome before settling back. The shock wave traveled through rock strata, crushing and collapsing the gas channel. Almost immediately, the result engineers hoped for began to unfold. The towering column of fire started shrinking violently, flickering, destabilizing, and then it went out. After months of unstoppable burning, silence fell. Only smoke rose from the sealed crater. Measurements confirmed that the gas escape had been completely blocked. The operation was declared a success.
This case demonstrated that underground nuclear explosions could serve as an extreme but effective tool for industrial disaster mitigation. The method was later used several more times to eliminate uncontrolled gas blowouts. However, each operation required unique geological conditions, flawless calculations, and carried potential radiation risks. Despite the underground containment, specialists closely monitored possible soil and groundwater contamination. Over time, the peaceful nuclear explosion program was scaled back and most data classified. Today, information about Project Fakel has only been partially declassified, and many operation sites remain remote industrial exclusion zones. Nevertheless, the project stands as one of the most astonishing examples of humanity using atomic power not to destroy cities, but to combat a natural industrial catastrophe unleashed from the depths of the Earth. It was an era when engineering ambition embraced extreme solutions, and the cost of failure could have been catastrophic. The story of Project Fakel remains a reminder that even the most destructive technologies can be used for constructive purposes when guided by precise calculation, necessity, and the urgent need to stop a disaster that could not be extinguished by any other means.